Today we are discussing about Rolle's theorem. Rolle's theorem that state if a real valued function f of x, if a real valued function f of x is continuous in closed interval ab, remember this is closed interval ab, continuous on closed interval ab, it means it is continuous in that end points also, continuous in end points. This is left end, this is right end, in that point also it is continuous, not a breaking. It is differentiable in open interval ab, it is differentiable in open interval ab. And third condition is f of a equal f of b. The mean, it means f of a equal f of b means the height. Here you can see this is a point a and this height is f of a, this point is b and this height is f of b. They are equal, they are equal. Then if f of a equal f of b, then there exists at least one real number c, there exists at least one real number c, here you can see c, in the interval ab means open interval, such that f dash c equal to 0. That means f dash c equal to 0. This figure, or from this figure also, this is a, this is b, this is a point c, and here is f dash c equal to 0. You know f dash c in first derivative 0 means the slope of the tangent is parallel to x-axis. Again, I want to define this Rolle's theorem. It states that if a real valued function f of x is continuous in closed interval ab, differentiable in open interval ab, f of a equal to f of b, this is the main part of this theorem. F of a and f of b shows the height, or that is y. Yes, you know this height. If a, f of a is this height, and b, this f of b is this, and throughout this curve, if we measure the height on that curve, f of a equal to f of b, after getting this f of b equal to f of b, continuous in ab, differentiable in ab, open interval ab, then third condition is f of a equal to f of b. If f of a equal f of b, then there exists at least one real number c in the interval ab, such that f dash c is 0, either in concave upward or concave downward. The nature of curve you can see in this way. When f of a equal to f of b, this is the Rolle's theorem. Now we will interpret geometrically geometrical meaning of Rolle's theorem. You can see up to this point this is f of a, up to this point this is f of b, they are equal. And if the curve of the function y equal f of x is continuous from the line x equal to a to the line x equal to b, from here to here it is continuous, there is no break on the curve throughout closed interval a comma b, having everywhere definite tangent. Everywhere you can draw the tangent, everywhere you can draw the tangent in throughout this curve, having everywhere definite tangent. And if the coordinates of n points are equal, you know these are equal, if the coordinates of n points are equal, then there exists at least one point on the curve where the tangent is parallel to x-axis as shown in the figure. So everywhere you can draw the tangent throughout this curve. But if f of a equal f of b, y coordinates is, then there exists a point c, there exists at least one point on the curve, here, this point, then f of c here, f of c, where the tangent is parallel to the x-axis. So f dash c equal to 0, or there is a point on the curve c comma f of c point, where the tangent is parallel to x-axis. This is the geometrical meaning of Rolle's theorem. It will be given in board examination also. You have to copy this. Okay, first state the Rolle's theorem, that is first one. This is the statement of the Rolle's theorem. Without figure also, up to here you can write. This is the statement of the Rolle's theorem. This is the geometrical meaning of the Rolle's theorem. This is the geometrical meaning of the Rolle's theorem. At this point, the tangent is parallel to x-axis. This is Rolle's theorem. So remember, f of a equal to f of b, differentiable and continuous in closed interval, differentiable in open interval. F of a equal to f of b, then there exists a point c from where the point c where f dash c equal to 0, or tangent is parallel to. Geometrically this is mentioned. Now moving to next part, Lagrange's mean value theorem. This is also called first mean value theorem. Lagrange's mean value theorem, or that is called first mean value theorem. It states that let f be a function that satisfies the following hypothesis. F is continuous on closed interval AB. This is similar to Rolle's theorem. F is differentiable, or f of x is differentiable on the open interval AB. This is also similar to Rolle's theorem. Then there is a number c in open interval AB such that f dash c equal f of b minus f of a by b minus a. It gives the slope y2 minus yn by x2 minus x1, like that. Okay, there exists, then there is a number c in AB, open interval AB, such that f dash c equal f of b minus f of a by b minus a, or equivalently, if we multiply this, f of b minus f of a equal to f dash c b minus a. This is the statement of Lagrange's mean value theorem. So first is continuous on closed interval AB. Second is differentiable on open interval AB. There is a number c AB such that in AB, open interval AB, such that f dash c equal f of b minus f of b by b minus a, or equivalently fb minus f of a equal f dash c b minus a. Now geometrically we can see here geometrical meaning of Lagrange's mean value theorem. I will show you here. If f of a, if f of a equal f of b, then you can see that is Rolle's theorem. Rolle's theorem can be applied, but always f of a does not equal to f of b, then the next theorem is derived by the mathematician. That's why, what's the geometrical meaning? If f1 a and b are not equal, then what will happen? Their condition is that, so if the curve of the function y equal to f of x is continuous from line x equal to a, this line is x equal to a, to this line x equal to b, having everywhere a definite tangent, and everywhere we can draw the tangent in this interval, then there exists at least one point on the curve, this is a point curve where the tangent is parallel to the curve joining the endpoints of the curve. So here is a point C. From that point, if we have drawn a tangent, then that tangent is parallel to the chord, joining the endpoints of the curve. This is f of a, this is f of b. From here, if we have drawn a chord and the slope of chord is alpha, and from here or this point we have drawn a tangent, the slope is alpha, so that is alpha and alpha equal, that's why these two are parallel. So this means, so here I have mentioned f dash c equal to f of b minus f of a by b minus a. We can verify in this way, so that f dash c is the slope of the tangent, and this is y2 minus 2 points formula, you know, x2 minus x1 like that. So their slope are equal here. So if f of a and f of b are equal, then there exists a point from where tangent is drawn that is parallel to x-axis. That is Rolle's theorem. If f of a and f of b are equal, if they are not equal, then what will happen? Then if they are not equal, let's see, suppose they are not equal, this is f of a, this is f of b, then we can draw this way. This is a chord. Then here exists, throughout this curve there exists a point where we can draw a tangent. The tangent is parallel to the chord, that gives by the Lagrange's mean value theorem, or simply mean value theorem. Mean value theorem. So it may be like this, here like this. In any form we can find, we can obtain. So here the slope of the chord equal to the slope of the tangent in Lagrange mean value theorem. In Rolle's theorem, there exists a point from where the tangent is drawn, which is parallel to x-axis. Tangent is parallel to x-axis, or f dash c equal to 0. Slope 0 was in that tangent is parallel to x-axis in Rolle's theorem. But in Lagrange mean value theorem, from a point, there exists a point from where we can draw the tangent. The tangent or the slope of the tangent is equal to the slope of the chord joining the endpoints. तो दुईटा एन्डपोइन्ट्सहरु जोडेर बनेको कर्डसँग टेन्जेन्ट प्यारलल भयो भने ल्याग्रेन्ज मिन भ्यालु थ्योरम सेटिस्फाइड भयो। होइन, दुईटा एफ अफ ए र एफ अफ बी इक्वल भएको बेलामा त त्यस्तो होइन। ठ्याक्कै के हुन्छ भन्दा देयर एक्जिस्ट पोइन्ट फ्रम वेयर द टेन्जेन्ट इज ड्रन व्हिच इज प्यारलल टु एक्स एक्सिस, और एफ ड्यास सी स्लोप इज 0 इन द्याट पोइन्ट। यहाँ स्लोप 0 हुन्छ। यहाँ चाहिँ ड्र गरेको टेन्जेन्टको स्लोप कर्डको स्लोपसँग इक्वल हुन्छ। यो कन्डिसन भनेकै ल्याग्रेन्ज मिन भ्यालु थ्योरम हो। अब सम्झिनको लागि फर्स्ट कन्डिसन सेम। फर्स्ट कन्डिसन, लेट मी ब्याक। First, continuous same, differentiable same. In Rolle's theorem, we have to remember this condition: f of a equal to f of b. Then there exists one real number c in the interval where f dash c equal to 0. By putting f dash c equal to 0, we can derive the value of c in Rolle's theorem. But here we can apply the slope of the tangent. This is slope of the tangent equal slope of the chord. Here slope of the tangent equal to slope of the chord. In first, f dash c equal to 0 means the tangent is parallel to x-axis, or first derivative is 0. Using this condition, we can verify Lagrange mean value theorem and Rolle's theorem. Then one more condition is, if any one of these three conditions, out of these three conditions, if any one fails, then we cannot verify Lagrange mean value theorem, and in respectively in the Rolle's theorem as well. Now we have to go to some information, extra information, that is continuous function. We have to go through this continuous function. We have to apply that condition. We have to, while verifying the Rolle's theorem and Lagrange mean value theorem, we have to test the continuity. So to test the continuity, we should be aware about some information. If you are aware, or if you are familiar with this condition, then you can write directly at that point. The first one is, a constant function is continuous on R. That we have discussed last year as well. Constant function is continuous on R. Identity function f of x equal to x is also continuous on R. Every polynomial function, it is very, very important. We have to use many times this. Every polynomial function is continuous on R. Every polynomial function is continuous on R. Sine and cosine function are continuous on R. Y equal to 10x is discontinuous pi by 2 and its odd integral multiples. Pi by 2, that 90 is discontinuous. E to the power x is continuous on R, and ln x is continuous on R plus only. the greatest integer function, this symbol is this, is continuous on R except its integral parts, that like this ladder, it becomes ladder like this, that in this point it will be discontinuous. In this way we can write the note.